Welcome everyone to this session. Today we have Julia Ferraioli, who is a technical program manager with Google's Open Source Programs Office. Julia will be presenting Preventing Random Acts of Metrics in Open Source Ecosystems. Just a quick note to attendees to please post your questions in the Q&A box instead of the chat. And Julia, a reminder to start your timer. Off to you.
Awesome. Thank you, Brooke. I appreciate the intro. So hi, everyone. This is the Preventing Random Acts of Metrics talk. You may also hear me reference it as the PRAM talk. I'm Julia Ferraioli, and in case you are not looking at your screen or you can't see the screen, I'm a white woman with curly-ish brown hair wearing a flannel shirt because I am in Seattle and I'm contractually obligated to wear flannel at all times. I come from a traditional computer science background. I have my bachelor's from Bryn Mawr College and my master's in artificial intelligence and HCI from the University of Rochester. But underpinning all of that was the usage and deep appreciation for open source software. That's how I found myself working in this space. So myself, along with Amanda Casari, who couldn't be here today, we co-lead the Google side of OCEAN, which stands for Open Source Complex Ecosystems and Networks. In OCEAN, we study open sources as such, which is why we call ourselves open source scientists, and I'm particularly fond of the term archaeologist. So I'm here today to talk about what you should consider, as well as what you should avoid when you think about metrics for systems like open source. If you'd like to follow along on your own laptops, here's a link to these very slides with hopefully pretty accurate speaker notes. It's at bit.ly/wids-PRAM. So what exactly is open source? Well, there's a standard definition. It's maintained by the Open Source Initiative, the OSI. A major focus is on the software license that maintainers choose to license their code under. The OSI maintains a list of thoroughly vetted licenses that are acceptable to use with open source. While a software license is a list of rights and responsibilities for what you can do with software, there are additional requirements the open source definition specifies in order for it to qualify as open source. I like to call the open source definition, or the OSD, the minimum bar for open source software. This, however, is not a definitions talk nor a licensing talk. I can give those, but they're very different. In every industry, there's the same joke, and open source is no exception. If you ask N open source experts what they mean when they say open source, you'll get N+1 answers at a minimum. Now, when we talk about open source, we talk about more than just the open source definition, more than that minimum bar. Open source has evolved to represent a framework that shapes how software is created, released, shared, used, and distributed, as well as the communities themselves and how they form around projects. Additionally, depending on what lens you use to examine these frameworks, you can determine different types of interactions of and between open source ecosystems. Because we know that open source is not just technical projects, but a combination of systems of technical and social components, it is actually a socio-technical system, which is a word I hope to hear more and more as time goes on. So let's break down what that means a bit. When we examine a socio-technical system, we have to consider the technical components and infrastructures. This includes code bases, hosting, CI/CD, packaging indices, metadata from mailing lists, or the social components. This is the people, the communities around projects, languages, topics, governance, and the social contracts that they agree upon together. And finally, the interactions between these different systems. Right now we have a lot of research touching on the technical or the social, but very little about combining it into one. The socio-technical element is why measuring open source is difficult. We have the gut instinct that open source is critical to modern businesses, but we don't have an agreed upon way of measuring it. It's not that people haven't tried, but a major problem is around data and metrics. Nadia Edbal outlined this problem in her Roads and Bridges report, and I'll link to that in the resources section of the deck. Usage metrics are either highly inaccurate or simply unavailable. This is not an easy problem to solve for. But without data about which tools are used and how much we rely upon them, it's hard to paint a clear picture of what is underfunded. Software funding for open source is a hot topic, as more so than ever. She continues to postulate that with better metrics, we could describe the economic impact of digital infrastructure, identifying critical projects that are lacking support, and understand dependencies between projects and people. This is a really fantastic report. I highly recommend reading it. So now that we've defined a gap in the industry, let's talk about how to define better, more meaningful metrics in the context of open source. Better metrics focus on useful metrics. So this fairly straightforward approach can help guide you through the creation of metrics. First, we want to identify our objectives. Then, define their observable aspects. Establish a baseline, or multiple baselines, the case may be. Define your trends, or desired trends. And finally, determine your signal phenomena. Let's walk through this step by step. It's so tempting to determine what you can measure first when thinking about metrics. That approach can lead to an abundance of data collected, but it can also lead to misleading metrics. Instead, first you need to identify your objectives. And that means thinking about what you want and what you care about. If you can't answer both A and B, it's time to go back to the drawing board. And remember, these aren't set in stone. As your project and its associated community change, you can always change them or formulate new ones. And I'm probably preaching to the choir just a little bit here, but just because data have been collected doesn't mean that they are useful. In a world of cheap storage, data is abundant. Next, it's time to define the aspects of each objective that can be observed. You need to understand how what you want actually works. Another way to think about an aspect is the trait. Choosing the aspects of your metrics is the most important step to remember that what you should measure is not the same as asking what you can measure. It allows you to reach beyond the easily obtainable data into information that truly tells the picture of your objective. Sometimes what you're interested in doesn't match up to the data that you can collect. In these cases, we can use proxy variables, which can kind of circumscribe what you're actually trying to measure. Now we can establish a baseline for each aspect you will measure. You can't measure progress or regression without understanding where you are currently. If you don't know where you are now, you can make an informed estimate in a few different ways. One way is to examine other projects to see where they are as an analytical starting point, then measure for a short period of time before you establish your baseline or reestablish your baseline. Step 4, define your desired trend. Remember, you need to know where you want to go. That's the only way you know that if you're off track or on track. Want more of something? That's an increasing trend. Want less of something? It's a decreasing trend. But I think the really underrated trend line that we don't talk about enough is when you want to stay the same. It's a steady state trend. I hope you all have appreciated these extremely complicated graphs that I generated for this slide. And lastly, we have step 5, determine your signal phenomena. Signal phenomena determine when a change in phenomena will appear in an observation. This is most important because you need to know what changes to expect over time and when they will impact you. Does your aspect capture events before the impact shows in other metrics? That's a leading signal. Does it capture events after the impact shows in other metrics? That's a lagging signal. This may seem fairly straightforward, and that's the point. The point is to be able to move you from what should we measure to talking with your team about, are these metrics useful in evaluating our progress towards our goal? And by doing it up front, it can set you up for success at every step of the way. But this 5-step process can fall short if it fails to consider the boundaries of the system it models. If we limit ourselves to the project itself, we are ignoring the impact of and on the community. We have to reset the boundaries around our metrics processes to include both the projects and their communities. We'll leave the term communities undefined, since that is another talk as well. So let's go back to the foundation that open source is a socio-technical system. This means we cannot focus on assumptions and goals directly tied to technical systems alone. We have to expand our abstraction level beyond the algorithmic framing. Here, when we talk about algorithmic framing, we'll be using the definition from the 2019 paper, Fairness and Abstraction in Socio-Technical Systems. They define algorithmic framing as choosing representations of data and labeling of outcomes. In machine learning, these choices are then used to compare the outputs to the inputs. Since this is the standard for most data analysis, where evaluative methods are chosen based on inputs that are compared to previous outputs, we can apply the similar methodology to open source metrics and analysis. The problem with this framing when examining socio-technical systems is that it creates too narrow of a view, and I quote, where abstraction is taken as a given and is rarely, if ever, interrogated for validity, despite the fact that many of these choices are made due to accidents of opportunity and access to data. Does that sound familiar? That we can measure and create models based on the data available to us, not necessarily based on the systems we want to be observing? As they continue to assert, the contrast to the algorithmic frame is a socio-technical frame, which explicitly recognizes that models and analyses are part of a socio-technical system, and that the other components of the systems also need to be modeled. We can get there by first knowing what kinds of problems these limited abstractions create, what this work defines as abstraction traps, and how to mitigate them. Let's introduce these abstraction traps, and then we'll walk through a concrete example where you might see them in the process of creating metrics for open source. First, we have the framing trap. This is when we fail to model an entire system over which a social criterion will be enforced. Next is the portability trap. The portability trap occurs when we fail to understand how repurposing algorithmic solutions designed for one social context may be misleading, inaccurate, or otherwise do harm when applied to a different context. I think we've probably all seen this when a machine learning model that's applied to one social context does harm when actually applied to another environment altogether. Next, we have the formalism trap. This is when we fail to account for the full meaning of social concepts, which can be procedural, contextual, contestable, and cannot be resolved through mathematical formalisms. And as data scientists, this kind of can make us feel a bit uncomfortable. Next to last, we have the ripple effect trap. This is when we fail to understand how the insertion of a technology into an existing social system changes the behavior and embedded values of a pre-existing system. I like to think of this as the prime directive trap. The final trap is actually my favorite. It's the solutionism trap. This is when we fail to recognize the possibility that the best solution may not involve technology. And again, this one is pretty uncomfortable for us as technologists because we like to solve problems and we like to use what we know to solve problems. However, the solutionism trap exists, and I have applied it and avoided it several times throughout my career. To tie concepts of creating useful metrics and abstraction traps together, I'd like to walk you through a concrete example. So, I like using Go. It doesn't have a huge following in the data science sphere yet, but I wanted to speed it along by creating a totally fictional data science library called GoNum with a B. There is a GoNum without the B, which is in fact a real data science library. So we've written it entirely in Go. We are eager to get feedback, grow our user base, but we're releasing a data science library, so we're also scientists. Before we launch our library, we want a process to help us know whether our work is moving in the right direction. Here's how we might go about it. Love the scientist gopher. I think it's so cute with its goggles and lab coat. Okay, back to the topic. Our first step, remember, is to identify our objectives. We've identified 3 possible ones. Is our target user adopting it? Is it gaining traction amongst the data science gophers that are out there? Is it easy to set up by themselves? And finally, does the library meet the user's needs? Those are 3 worthy objectives. But let's focus on just one, which is it easy to install and set up the library? First of all, what does the setup process look like? Well, we have to find the library first. So maybe we're experienced in Go, so we know to go to Go's package registry, and I recognize the awkwardness of that sentence. But once we're there, we can read the documentation. Based on what we've read, we can make a decision on whether this Go package is the right one for us. Once we're sure, we use Go's tools and install the library on our computer, running a tool called GoGet. Finally, we build our first application using the GoNum library. We're going to pause for a moment here. We're about to fall right into the formalism trap. Although we're doing our best to outline the process from our point of view, we may not be able to fully account for all of the concepts that impact or can be observed for an installation. Not all social concepts can be represented or explained through mathematical formalisms. For example, in the make a decision step, there are potentially procedural or contextual concepts which may prevent people from adopting our library. One such concept is the license attached to our library. Many companies or projects have policies around which licenses they allow. So depending on the license that we've attached to GoNum, it might not work out for them. And our library is just starting out, so maybe it's missing key features that our users are looking for. We have no way of capturing those data in this metrics pipeline because we lose the users before we can even start measuring them. Okay, it seems like tackling the whole discovery to installation process is still a bit too broad. Let's narrow it down to one specific aspect that we can sink our teeth into: the process of pulling the library onto a user's computer or development environment so that they can build against it. What can we measure about the installation itself? There are two things that immediately come to mind when you're thinking about a successful installation. Can you install it, literally download it and bring it onto your computer? And can you build against it? But these things can't necessarily be properly measured without building software that so-called phones home. And that has all sorts of privacy and security implications. So we're not going to do that. Instead, we're going to have to use proxies to approximate them. Some proxies that occur are things like number of downloads, the issues being filed, any questions around the installation documentation, as well as contributions that touch any installation-related scripts. What assumptions are we making about not just successful installation, but installation at all? Pulling apart the question of installation, we discovered that it's not nearly as straightforward as we or the open source ecosystem might think. Even as we dive deeper into the granularity of installation, there are some unspoken assumptions. For instance, does the user have access to source control? This might not be a technical limitation, but a social one. Do they have Go installed on their system, or will they be grappling with an uncaptured dependency? And all of that assumes that they have a compatible system that an algorithmically intense data science library can run on. The last one I'll mention is one that we don't consider enough, and that's around bandwidth. Does our user have access to sufficient bandwidth to actually download the library? And this question revolves around socioeconomic questions, geographical questions, things that many of us often take for granted. If we assume that our download data paints a clear picture of our user base, we quickly fall into the framing trap by failing to fully account for all users who could be working with our technical system. We can mitigate this by adopting a heterogeneous engineering approach, which means that we simultaneously factor in the technical components as well as the social components, aka the human factor. For example, here the metadata from successful downloads, such as geographic region, only shows part of the picture. We cannot say we are doing well in this country from this metric. Rather, it allows us to ask better questions like, what drove downloads in this area? Why are these users able to successfully download here? And what other blockers to a successful download might exist for users in this area? By moving to a socio-technical frame, we are able to ask more pointed questions about the data itself, including who are we including? Who are we excluding? Are we deliberately making those choices, or are they the consequence of the framing trap? When we examine the socio-technical side of the data, we can also query whether our underlying assumptions about who our users are faulty. Great. We've skirted the framing trap. Let's move on to establishing a baseline. Again, you need to know where you are now. But we don't know where we are now. We are a new library. But we can make an informed estimate to try to back into a baseline. This can mean looking at other libraries and using their historical data to inform our expectations. then we start measuring and see how our metrics measure up. And this is where we have fallen straight into the portability trap when trying to estimate where you are and where you want to be. The problem with this can be when you're not able to accurately assess when solutions to questions from one context will lead you in the wrong direction. In this case, comparing to other types of Go libraries could be misleading and inaccurate for a data science specific Go library. Data science has many dependencies in a project, such as access to data, scientific computing libraries. Go is, again, not high on the list as a preferred language for data scientists. So here, you want to focus on assumptions for your specific application, domain, programming language, community needs. If you cannot find a good analog, start at the beginning, at 0. We've avoided the portability trap and have established some baselines. Our next step is defining our trend. Again, we can't measure successful installations directly, but what we can measure is the number of downloads, whether it's increasing, the number of issues filed, if it's decreasing. If we see the number of installation issues decreasing, can we safely interpret that to mean that the number of users who experience difficulties have gone down? And coupling that with increased numbers of people downloading the library, that seems to be a clear indication of an easy install process. We've slid into the solutionism trap. We've done a decent job so far reminding ourselves of the human component and social context surrounding our library. But we've fallen into the solutionism trap by assuming that our metrics process and approximations are telling us the story we need to hear. Dashboards and metrics can be indicators of project health, but may not contain all the nuance and unmeasurable attributes you need to understand to make project decisions. Because human preferences are not rational and human psychology is not conclusively measurable, you cannot fully quantify your community or your users through automated pipelines. You must continue to build communities, not audiences. You want to develop bidirectional relationships with your contributors and users. Ask them open-ended questions. Learn from their experiences and what shapes them. Our final step is determining signal phenomena. An increase in platform support requests could indicate an increase in the number of types of users. This would be an example of a leading signal or a leading indicator. An increase in the submitted patches to installation documentation could be a lagging signal or a lagging indicator. So at the end of the day, remember that the metrics you choose are a reflection of what matters to you, your project, and your community. It will take extra work to broaden your view, to dive past what we can measure, and to dive deeper into what matters to be measured, and to avoid the abstraction traps that we have seen are pretty easy to fall into. If your goal is not to just release work, but to foster and nurture the open source ecosystem that we pretty much all rely upon, then I think we can agree that the extra work is necessary for the common good. After all, we're all in this raft together. So some resources. Here's the link to the Roads and Bridges report by Nadia Egbal. I also highly recommend taking a look at her latest work, a book called Working in Public. Next, we have a link to the Fairness and Abstraction in Socio-Technical Systems paper. And the final two links revolve around OCEAN, this open source complex ecosystems and networks project that we the University of Vermont Complex Systems Center is running in collaboration. We have some grants available for anyone. It doesn't have to be just for academic institutions. But if you are interested in open questions around open source, consider applying. They range from micro grants to more fully fledged grants. And you can check out our GitHub repository. So thanks, everyone. Again, Julia Ferraioli. And I think we have some time for questions. Let's see.
Awesome. Thank you, Julia.
Oh.
Thank you for your talk. You're welcome to stop sharing your slides or leave your contact information up if you want, whatever you prefer. We can wait a minute and let questions roll in. I know it's hard to sometimes listen to these things and type out questions in the moment. And yeah, so let's give 30 seconds, and then I also have a question myself if we're still waiting on a couple attendee questions at that time.
Sounds good. This is a really fascinating area, especially around open source, which wants to be very data-driven, but is limited by a lack of data, of existing data. I'm going to go ahead and stop sharing the screen.
All right, well, we wait for people to potentially type in questions. One question I have for you is, what is an example of an open-ended question that you would pose to communities using an open source project? Like you talked about in, defining your desired trend, maybe a metric won't do it. What's an open-ended question you might use instead?
I mean, a behavioral question would probably be a good example. So providing a short form text entry to what kinds of applications are you building, or what are the goals of the applications that you're building. Additionally, if you're to kind of zoom in on the installation experience, what kind of issues did somebody experience, or what kind of development environment do they use? That would be a really interesting one, moving past the installation experience, because if you wanted to gather information about the platforms, the types of editors, the types of tooling that people use, then you could prioritize developing integrations for them based on the input that your users are giving you. But I think open-ended questions for us are so intimidating because there's the A creating them without biasing your respondent, which is definitely an issue that I see in the surveys that I take. And analyzing freeform text is not a coveted thing for folks necessarily. It's easier to put things on a 1 to 5 scale, but you lose so much if you only go with that approach.
Awesome. Well, I have certainly learned a lot of useful framing from this talk. It definitely gave a lot of concrete words to things I've experienced. So thank you very much for this. I'll definitely be following up with some of those resources. So this concludes our session for today. If you have any additional questions for our speaker attendees, please send a direct message to Julia in Excel events or in Slack. And we look forward to, oh, go ahead.
or on Twitter. My DMs are open.
Awesome. Thank you so much. And we look forward to seeing you all, speaker and attendee, in the following sessions and expo booths. So thank you so much and enjoy the rest of the conference.